Hello and welcome. In today's video, we will be covering the basics of the NestJs framework. It's the first part of the series where we will be implementing the recipes API. It's a hands-on tutorial, so please open your code editor and follow my steps. You can find the link to the final code inside the description of the video. Okay, without any further ado, let's get started. To start working with the NestJs framework, you have to install the Nest CLI first. For that, type command npm install globally nestjs/cli. After successful installation of Nest CLI, please go to the directory of your choice and type command nest new project name. I will name my recipe API. During the project initialization, you will be asked to pick the package manager. For this tutorial, I will pick the npm package manager. The full initialization may take a while. Nest is installing plenty of packages for us, and it's creating a basic app structure. Unlike the Express.js, Nest is opinionated framework, which means that the creators of framework and the community decided which packages we should use. Nest also suggests us how to structure our code. In fact, Nest is highly inspired by an Angular. If you know Angular, learning the Nest will be an easy task for you. Nice, my project is initialized. Let's enter the project in the terminal. For that, type cd and project name. As you can see, Nest started the Git for us. The main branch is created. Let's quickly reveal what the Nest has created for us. Starting from the bottom, we have a TypeScript config file. Nest is supporting the TypeScript by default. Then there is a README file and package.json. When you are inside the package.json, you will see many scripts already created. There are scripts for starting production or development app. There are scripts for linting and testing. Nest has set up all of those scripts for us. Great, that's such a neat start. Then, there we have a few config files. We have a config for a Nest CLI and the pre-tier. We have a git ignore file, and finally the config file for linter. Inside the Nest project, there are two directories we should be aware of. First one is for the end-to-end tests. The approach is simple. Unit tests should be as close to the classes as possible, so we don't put them to the test directory. Here, we only keep the end-to-end tests. Unit test and the whole code of application is kept inside the src directory, and that's the directory on which we'll be focused today. The most important file inside the project is called main.ts. It is the entry point of our application. Here, we are creating main module using the Nest factory class. Then, we listen on a specific port for incoming connections. The last line is just a simple invocation of a method. Okay, but beside the main file, there are also modules, controllers, and services. What are they? To fully understand that, let's quickly look at this picture. These files are called this way because NestJs by default is implementing the layered architecture. In this approach, we divide our code by some logically similar units. Firstly, we have the controllers. They are the only way for the outside world to communicate with our API. In other words, they expose public endpoints and manage them. Then we have the services layer. Services are the heart of the application because the business logic is living in the services. They also interact with the data layer, which is responsible for a data persistence. Controllers, services, and data layer together make a module. Small disclaimer. In NestJs there are other types of code units like guards or pipes, but they are not related to layered architecture. For simplicity, I will cover them in a separate video. Moving back to modules. We create modules because they allow us for a better code separation. If we work on a larger app, the code base is becoming bigger and bigger. It's very convenient to divide the app by its domains. logical parts. For example, we could have an app having the users module, recipes module, and the cron job modules. All of those modules are aggregated in the app module in the NestJs app. So, knowing that, let's move back to our project. That's our app module. It's just casual TypeScript class. What is different is that we use module decorator. Here you can pass a few options to that decorator. You can import other modules, or you can register controllers or services to be alive to dependency injection. Here is another disclaimer. In Nest module, there is no separate file for registration of services. There is general field called providers where we register our services, but we can also register other types of entities. Next, we have the controller file. To create a controller, we have to create a class and annotate it with a controller sign. We also have to register it in the module, as I've shown you just before. To create an endpoint, we have to create class method and annotate it with a specific REST method. In this case, we have the get endpoint. Finally, in the constructor, we have the app service injected. In general, when working with NestJs framework, we don't initialize anything. We just register things in the module, and the Nest creates the objects in our behalf and injects them to the required classes. Finally, we have an app service. To create a service, we have to create a class and annotate it with an ejectable decorator and then register it in the module. In this example, getHello method returns the hello world string, and that's all what it does. But enough talking. Let's start the server and check if all is working as I said. To start, let's use the npm run start dev command. It will start the development server. By default, when starting the development server, Nest will restart the server each time when we save any file. Great! You can see the message that the Nest application successfully started. To test the API, I'm using the Visual Studio Code extension called Thunder Client. It's a copy of a Postman, but it works inside the Visual Studio Code. It's more convenient to me. But you can use any client you want to. So here, I will try to send the GET request to the local host on the port 3000. That's where our app is running. Yeah, as you can see, our API responded with a message. That's a good start. Now we will work on the actual app. For that, firstly, I will delete the Hello World controllers and services. Here, you can see an error message. It's because I've deleted controller and service, but they are still imported in the module file. We have to delete them here as well. Cool. Now the app is working again. Now, I will show you a few helpful commands from the Nest CLI. To create the module, please type NestJs mo recipe. Nest is a global script we have installed on the beginning of the lesson. Next, G stands from generate, mo stands from the module, and at the end we're just providing the name of a module. After invocation of this method, Nest created a new directory and a module inside it. Next, we will create the controller by typing the NestJs recipe. It's the same as with a module. We are telling Nest CLI to generate something. CO is just abbreviation of a controller. As you may notice, Nest also created a unit test file for our controller. Finally, let's create a service by typing NestJs recipe. If you open the recipe module, you will see that the controller and a service are properly imported inside this module. That's neat automation from a Nest side. We will start implementation of our API from creation of endpoint for fetching all available recipes. Let's create method getRecipes. I will mark it as an async method. To be honest, in this video I won't use any async calls. For simplicity, we will use in-memory store. However, in the next video, I will show you how to work with real database. Then I will do an async calls. So I will implement the controllers this way that I won't change them in the future. I will only refactor the services code. Okay, going back to the code. To create the endpoint, we have to annotate the method. We want to fetch data, so it will be a get endpoint. This decorator comes from nest/common package. There is no direct access to the data layer in the controllers. For that, we use services. So we have to inject the recipe service to the controller. The whole dependency injection is managed by a Nest framework. We only have to annotate the class with specific Nest decorator, like controller for controllers or injectable for services, and then register it in the Nest module. Then we only pass the class to the constructor, and that's it. Nest resolves all of the dependencies for us. Let's implement the method for accessing the recipes in the service. Again, I will mark the method as async. It's for future purposes. To implement that, I will create two more things, the DTO and the entity. DTOs are used to structure the incoming data, while the entities are used to map the database model to app objects. Our recipe DTO will have the following structure. It will contain a description and an array of ingredients. Single ingredient will have a name and unit and quantity. Finally, the quantity will be an enumeration type. Let's also create the entity. It will have the same structure as recipes DTO, but beside description and ingredients, it will also have an ID to distinguish recipes between others. Because today we are working without an actual database, I will create a recipe variable to hold all of our recipes. The getRecipes method will return all recipes added to recipe array. I have also marked the method as asynchronous, even though it's not asynchronous now. I did that for a purpose. In next episode, when I add a real DB, this small feature will decrease the amount of refactor. Moving back to the controller. Here, we will simply return a result of getRecipes method from a recipes service. And that's it. As you can see, the node process is still running. The Nest will recompile the code for us, so we can test it out. I will copy the recipe string from the controller annotation and move to the Thunder client extension. Now, I will add it at the end of the URL. Let's click send and see what will happen. Great, we have received status 200 and empty array. We have empty array because we don't have any data yet, so everything is working correctly so far. Let's move back to our controllers file. There, I will add a new method for saving recipes. I will name it createRecipe. To create the recipe, we will use the post method, so we have to use the post decorator. It comes from nest/common package. The method takes recipe DTO as an input, but how can we access it? There is another decorator in the Nest framework. We have to add body annotation before the actual input. This way, the framework will parse the body from the HTTP request and pass it to our method. We will also follow the same pattern as in case of getEndpoint. The business logic will be implemented inside the service file, so let's implement the required method. The createRecipe method will take recipe DTO object and simply return promise void. Again, it's marked this way for future purposes. Inside the method, I will create a new variable called recipe entity. I will assign the whole DTO object to it and add the generated ID. For ID generation, I will use the v4 method from UIID package. Finally, I will push the entity to the array. So the last thing to do is to use this method in our controller file. Let's invoke it. Now we are ready to test it in our HTTP client. The endpoint is the same as before, but the HTTP method has changed. Now it has to be a post method. I have created some setup before. There is some dummy body which I will send to the server. Let's click the send button. Great, 201 status. It means that entity was created. If you have watched closely, you may ask why there is 201 status returned. We didn't set it. So the answer is that Nest did it for us. The 201 status is default option for post endpoint. Now let's examine if the data was saved correctly. To do so, let's use the get endpoint. When we hit send button, we should immediately see the list of recipes. Yes, it works. Moreover, the ID was added to our record. Cool. Having this functionality ready, let's go back to the controller's file. Now, it's good time to create the endpoint for fetching single recipe. It will be also a GET request, but this time we will also add a path parameter. Inside the GET decorator, please type /:id. It's super important to add a colon sign. It will be treated as a variable by a Nest framework. Speaking from client perspective, we will be sending different recipes IDs depending on entity we want to get. To access it, we have to use another decorator. It's called params. And inside parentheses, we have to pass the name matching the name from the get decorator. As usual, let's move back to service and implement the business logic. Let's name the method in the same manner. It will be called getRecipe. It will take ID as a parameter and it will return promise with a single recipe. Again, I'm making the method as async for future purposes. It will help me when I will add the database. Here, I will use find method to search inside recipe array. If there is no recipe found, I will throw an error. It's safe to do that. It's HTTP exception from Nest command package. The exception will be handled by the Nest framework and the proper message will be returned to the client and status 404 will be sent. Finally, if there is a recipe, we simply return it. And that's it. Let's use this method in our controller file. Just pass the ID and await for a result. Now, let's move back to the Thunder client to test it out. But when we copy the ID of the last added recipe and we try it out, it won't work. I mean, it returns 404. It's that way because we don't have a database. The records are held in a memory. So, when we have saved the files we work with, the NestJs framework rebuilt the app. The rebuild removed our records from the memory. Therefore, we have to add a new recipe. Now, when we grab a new ID, we should be able to fetch it by ID. Yes, now it works. As a result, we got an object, not an array of objects. Cool, another endpoint done. There are two more CRUD operations left. Let's implement them. Let's start from implementing some update. Just for simplicity, we will create a method for updating the description of a recipe. The video is already long and I don't want to make it longer than necessary, but feel free to add endpoint to update a whole model. Okay, moving back to code, let's create update description method. For that, I will create a new DTO object. Let's call it update description DTO. That will be really simple class. It will have only one description field of type string. So, in our controller, we will again use the body decorator, but this time the type of input will be different. Next, we have to annotate this method with a patch decorator. It's another one decorator from nest/common package. We also have to add the /:id to the decorator. Patch works on a single element and we have to match the ID in our method with the ID from the request URL. So the second parameter of this method will be the string ID. It will be annotated with param decorator as well. Now, let's implement this method in the service. I will name this method update description. It will take the ID and the description as an input parameters. This time, I will search for index of the entity matching my ID. If no entity is found, the index will be -1. So, in that case, I will also throw an error. It's the same case as in the getRecipe method. But when the recipe is found, I will update the recipes array on founded index. Here, I simply copy the whole entity, just overriding the description. So, that's it. The method is done. Let's use it in the controller. Once again, we simply invoke the method, return the awaited result of this method. There is a small improvement we can do. Currently, we have the description DTO and then we access the description. We could unwrap it directly inside the method declaration. Let's do that. Now the code is shorter and cleaner. So, let's test this method once again. As previously, the array of recipes is empty because Nest has reloaded the app. We have to add one recipe first. Cool, created. So let's grab the ID of the record and then change the description. Again, I have prepared the endpoint. Its path is the same as the getRecipe, but the ID has changed, as well as the HTTP method. Now the method has to be set as a patch. Moreover, we have to pass the body to the endpoint. Let's edit the description a little and click send. Cool, 200 status. Now, when I fetch this recipe once again, the description is changed. So, the last thing to do is add a new endpoint for removing recipes. To do so, I will create delete recipe method and I will set it as async. The name of the decorator is, as you can expect, delete. It comes as all of the other HTTP decorators from the nest/common package. Once again, I will grab the ID of the entity from the URL path. Then, I will use the param decorator to inject the ID to the method input. Inside the recipes service, I will add a method called deleteRecipe. Inside the method, I will filter recipes array. I will search for records having ID different from mine. Finally, I will assign this result to the recipes variable. That's it. Implementation is very simple. The last thing is to use it in the controller. Save it, and we are ready to test it out. One more time, we have to add a new recipe because we have lost all ones. Now, I will use the get endpoint to find the ID of a newly created recipe. Okay, got it. So now I can pass it at the end of the URL and change the HTTP method to delete. Let's click send. Great, success response. Just to prove it works, when I again use the get method, I should receive 404. Yep, the entity not exists. So, this way you have learned how to create all of the CRUD operation in the NestJs framework. That's an awesome start, but it's only the beginning. There are plenty of things to learn left. In the next video, I will be teaching you how to use TypeORM together with NestJs to persist your data inside a database. So stay tuned. Meanwhile, thank you for the watching and see you next time.